On to question 3. So the integral of x squared over x minus 10 dx. When you have x squared over a binomial being a term with an expression with two terms, x being one and negative 10 being the second, usually the easiest course of action to integrate is to first do polynomial division. So let's do that here. We've got x squared divided by x minus 10. I have a separate YouTube video on how to do polynomial division, so I'll run through this kind of quickly. If you want a more thorough explanation, just head to that video. But I'll explain it here. So we've got x squared. Now, the first thing to do is write a minus sign and a parentheses. Now we need to think, x times what is going to bring us to x squared? X times x gives us x squared. So now we write x up here, and then we multiply x times x, which is going to give us x squared in the parentheses that we wrote before, the minus parentheses. And then negative 10 times x is negative 10x. We're going to write that here. Now we subtract this binomial from the original x squared, which gives us 0 plus 10x. So we can erase the 0 and the plus for clarity. I'll make the 0 a little neater. Now we need to think x times what is going to give us 10x. The answer is positive 10. So let's write that, plus 10. We write that up here. So now, just as we did before, let's write the minus and then parentheses. Now let's multiply x times 10, and write that here, 10x, and then negative 10 times 10, which is negative 100, which when we do this subtraction, since a negative and a negative becomes a positive, it leaves us with only positive 100. Now, instead of multiplying by 100 over x to give us 100, we are just going to call this the remainder. This gives us the final answer of x squared divided by x minus 10 is equal to x plus 10, remember from up here, plus 100 divided by x minus 10. The 100 being the remainder, and then we're dividing by what we divided by before, x minus 10. This is the quotient when you do polynomial division here. Now recognize, since these are equal, instead of integrating this, we can integrate this. So our integral becomes and remember, this is equal to what we had before. This equals that. They're equal. And recognize how this is much, much easier to integrate than what we had before. So for clarity, I'll separate each of these terms since it's a sum, and you can separate it in integrals into 3 integrals since there's 3 different terms. So this is equal to the integral of x dx plus the integral of 10 dx plus the integral of 100 over x minus 10 dx. The integral of x is simply x squared over 2. And since it's an indefinite integral, we can put plus c here, but each one of these would have a plus c, so I'll only write one plus c at the end, since that's all you need to do. Just remember to do that. Plus the integral of 10 being 10x, and then the integral of this here, or let's just write plus c, since we're going to alter this. We can write plus 100, since we'll factor out the 100, times the integral of 1 over x minus 10 dx. To integrate 1 over x minus 10, let's do this on the side. Let's do u substitution. let's say u equal to x minus 10, meaning du is equal to 1 dx. Now we can substitute in u and du. So this becomes the integral of 1 over u du. Notice how this is equal to ln of the absolute value of u plus c. This means that our integral comes out to the ln, the absolute value of x minus 10 plus c. So when we bring everything together, it becomes, and again, I'll write the plus c at the very end. It becomes x squared over 2 plus 10x plus 100 ln x minus 10 plus c.